Okay, so for question one, first and foremost, plotted the Michaelis-Menten scatter plot here. So we have our substrate in the left column here, which is on our x-axis, and then our rate here, our VO, which is on the y-axis, plotted in that Michaelis-Menten scatter plot. And then for the Lineweaver-Burke, we just take the reciprocal of that substrate on the x-axis, did 1 over each of these numbers above to get this data here, and then same thing on the y-axis, just plotted the reciprocal, 1 over each of these numbers here was placed into the y-axis, and we get that Lineweaver-Burke plot, and then used Excel to just create that linear regression, that best fit line. And the formula for that line is right here at the top, y equals 3.11x plus 6.664. And so we'll take that data and we'll go ahead and calculate for Km and for Vmax. So we know for Km, we need to ultimately find the x-intercept. So we'll set y equal to 0, and then we will go ahead and solve. So we again use that linear regression formula, and we solve for x, setting y at 0. We do some math, and we find that x-intercept is negative 0.213, which is what we find here on our plot as well. And then to solve for Km, we will go ahead and do the formula Km equals negative 1 divided by that x-intercept. So just using the reciprocal then again to get 4.695 for our Km. So again, using the negative reciprocal of the x-intercept to get Km. For Vmax, we know we ultimately just need to find the y-intercept. So if we set x to 0 here, that 3.11 cancels out. We know that that y-intercept is ultimately 0.664. To solve for Vmax, we do the reciprocal 1 over 0.664, and we find that our Vmax is 1.506. So that is the data for question 1. Question 2, similar, but now we add the 2 inhibitors to this and see how they see what that relationship looks like here. So in the first graph here, again, just taking our data and creating another Michaelis-Menten plot. This plot on the left is just with our enzyme here. Okay, and then the plot on the right is now that enzyme plus the 2 inhibitors. So inhibitor 1, those data points are in red. Inhibitor 2, those data points are in yellow. And then the blue data points would be the exact same that we see here. All right, and then to our Lineweaver-Burke plot, same thing as we did in question 1, just take the reciprocal of each, and that's plotted here. As you can see, same thing in question 1, all the way across the board, we take the reciprocal of that substrate of the enzyme, and then each inhibitor, those data points here up top. All right, so on our plot here, on our scatter plot, the one on top would just be these 2 boxes here, and just looking at the linear regression here with that Lineweaver-Burke plot from this data. So linear regression here is 1.01x plus 0.889. So solving exactly the same as we did in question 1 to start, we find our Km and our Vmax using the same formula. All right, so first finding the x-intercept. That x-intercept is negative 0.880, and then solving for Km by using the negative reciprocal of the x-intercept. And finding that Km is 1.136, and then again for Vmax, finding that y-intercept, which we know is 0.889, and doing 1 over 0.889 to find that the Vmax is 1.125. Now, for this Lineweaver-Burke plot, when we add in the 2 inhibitors, we look at this plot here. So I put all 3 of these all three of these data points, or all three of these linear regressions in the same scatter plot here to be able to compare each one. So our blue line and our blue data points are the exact same as this plot here. The red data points are now looking at that enzyme versus the inhibitor 1 and how those correlate. And then the yellow linear regression line and these data points are looking at inhibitor 2 and how they correlate, again, with our initial line here. So again, we do the same math for the inhibitor 1 and inhibitor 2, the exact same. So we find doing that formula and going through the math of it, that Km for inhibitor 1 is 1.135 and the Vmax is 2.817 for inhibitor 1, and then for inhibitor 2, again, same formula. Find that Km is 0.383 and that our Vmax is 0.379. So what does this mean? So looking at the relationship between the enzyme and inhibitor 1, we find that this is a non-competitive relationship. The reason why we say this is we have sort of a mixed bag as far as how these correlate. So our Kms are, for the most part, identical when we look at this. 1.136 to 1.135. This is more or less identical, just 1/1000th off as we compare these. So that, combined with the increased Vmax, this relationship tells us that it's a non-competitive relationship between this inhibitor and the enzyme. Now, for inhibitor 2, we find that the Km, when compared to that enzyme, is relatively much lower. We also find that the Vmax is relatively much lower. So this is an uncompetitive inhibitor, and a couple of reasons why. One, we talked about the decreased Km and Vmax in relation to this enzyme, but the other thing we see is that these numbers are decreasing by the same factor. We have the same exact slope on these two lines, so the slope is 1.01 for both, and what that tells us is these lines are parallel, and again, that's a dead giveaway that this is an uncompetitive relationship. So findings are inhibitor 1 has a non-competitive relationship due to the relationship between the Km and the Vmax with the enzyme, and inhibitor 2 has an uncompetitive inhibitor because of its overall parallel features with the enzyme, that similar slope, and then we see the decreased Km and the decreased Vmax because of our calculations that we performed.